The title of my presentation is Introduction to Grid Technologies and Practical Usage of Grid Middleware. I am the presenter, Shalton Mothwa, from the University of Johannesburg and the Nuclear Corporation of South Africa, in conjunction with GINR. My supervisor is Andre Nechiaski from GINR Lab of Information Technology. The contents of my presentation are as follows. Firstly, we'll go through the introduction, aims and objectives, theory, equipment or experimental description, results and conclusion. The main reason why I said theory, equipment or experimental description is that in computing generally, theory, equipment or experimental description form one package that solves the problem. So you cannot do theory separately, equipment separately. You have to do them as a package. Then you will get results. So from the introductory part, computing started long time ago, about 8,000 years ago or so. So humans, ancient Greeks, ancient Egyptians, and other groups used their fingers to calculate and count the crops or whatever they were farming at that time. So as time goes on, it was very, very difficult to carry out computations using their fingers. Then the ancient Greeks invented the abacus, of which was much easier to use and more powerful to compute. So the abacus, there was a point where it could not do a major calculations again. Then as humans, as we always invent, then we came up with the calculator, an electronic calculator. So the calculator can do more powerful computations with ease at the higher speed compared to the abacus. But the calculator is limited. So we need something more powerful to do tedious and power demanding computations. Then we came up with the personal computer, of which is very, very popular these days, that we are using. So then what happens if our personal computer fails us? Then we have to come up with something. What is that thing? Now that thing is what we call grid computing. So in grid computing, we've got a cluster of databases, we've got supercomputers, PCs, laptops, that they are connected to the network. So in a nutshell, a computational grid is a hardware or software infrastructure that provides dependable, consistent, pervasive, and inexpensive access to high-end computational capabilities. So the components of grid are, as you can see in the picture, we've got users, we've got groups, we've got sites. All these components form what we call the grid. So in the grid, you can have a dynamic population that is large. You can have different accounts at different sites, personal and confidential data, and others. So groups, we have a group data, access patterns, and membership. You can become a member of a certain grid. So sites, we have a heterogeneous resources, access pattern, local policies that governs the grid, and membership again. Then the aim of this training is to teach applicants basic knowledge in grid and its concept, to give essential skills needed for further work, grid-enabled applications, and grid administration. Those are the purposes. Then in order to achieve the aim, there are 4 basic things we should know about grid computing. Is the security infrastructure, is the operations with metadata catalogs, data management, and job management. So once we are clear and understand these objectives, then it will be easier and more clear to understand grid. Then we should do equipment description, of which we start with security infrastructure. So for security infrastructure, it's just to get security clearance so that you can have access to grid resources. So we've got a user, we've got the internet, we've got grid resources, but in order to access them, you must have a digital certificate, register with a virtual organization. In this case is Edu Engine R. Then from there you can make a temporary proxy certificate. Then as we continue, we use a client server user interface. So in this case we chose PuTTY. As you can see, this is PuTTY interface. Then the host is VPS 101 R. .2, there is port 22. Then those are our default settings. Then from here, as we continue with the description, then one should create a proxy. Then once you create proxy, you can have access. Then from there, once you have a proxy, then you can start doing operations with the metadata catalogs, where you can issue commands to list directories, get information about files and directories, get information about rights, permission, and get other information about resources in the grid using the logical file catalog. Okay, then from there, there's the command you issue, LFC ls. So basically this is a command to list all the users in the grid. Okay, there are other commands, your LFC, make directory, list, and others. So as you can see, when you launch this command, then you can see your computing elements and your storage elements in the grid. So basically you issue this command to see all these resources. Then from there we can perform the data management using FileZilla for file sharing, where you can upload and download and play around with data. Then as we go, you can see you've got a user interface, user sitting somewhere. Then you have to register the files and upload them and play around with it. Then from there you can use the LCG copy and LCG register commands. Then from there, this is the actual data file copy and registration command, as you can see the first line there. And then once it's registered, it will give you the GUID number. Then from there, it tells us that the file is being registered in the grid with this unique ID. Then from there, you can copy the file to the grid. Then as we continue, we have to do the actual job submission. So job submission, you need a JDL file. A JDL file has the type of job, executable arguments, input, standard output, error output, sandbox, CP number, and the requirements. Then in this case, once you have your JDL and your executable file, then that's when we can start doing any project. Then we are ready now to submit a job into the grid. Then in this case, in my training, this is a mini project I was given to do, of which I was supposed to write a script that will upload the archive on the appropriate working node, unpack the archive, resize all the images from that archive using image utility, of which is installed in VPS 105 gin.r.ru. Then from there, I was supposed to pack this directory and submit it to the grid. And then from there, this is how my JDL looked like. Then the job type was normal. Then the executable was photos.sh, standard output, standard error. And then input sandbox was that one there, photos.sh. Then output sandbox was output.text and the error. Then the requirements was others.clue CET host name, of which is where I was supposed to get the archive and upload it back, is VPS 105.gin.r.ru. Then from there, this is how my executable file looked like. Then those are the commands you issue. You get the tar file, modify it. We resize the pictures in that archive using the software given to 100 by 100 in the extension of JPEG. Then we pack it again, then we send it back. And this is basically what I was supposed to do during my training. And then once you are ready to submit your job, you should just basically know how the work is loaded and managed in the system. So you can see from this picture, you've got a user there, user interface. Then there's authorization service first. Update your credentials. Then from there, you submit a job. Then in the file and replica catalogs. Then from there, it takes the query to the information system, and then to discover the state, the availability of your grid resources is either computing element or storage element. Then once it's allocated, then it will take it back to the information system, then do the querying. Then from there you can retrieve the job or check its status while it's busy processing. Then in a nutshell, as I've already explained how the workload management system works, this is the actual Gilead work management system. So as you can see, we've got the storage elements, we've got the computing elements. Then you can follow from the picture how the job is being submitted. Then you can see you can check your job status once it's submitted, waiting, ready, scheduled, running, done, or cleared. Then from there, if your job is done, then you can retrieve it, or if it's ready or any of those, you will take a further decision on what to do. Then there are types of jobs. We've got the single normal job, we've got the direct applied graphs, we've got collections, we've got parametric, we've got an interactive job. So in this case, due to time constraints, then I was supposed to do a simple normal job. But there are more interesting jobs, like the interactive job where you interact with other users. And then from there, that's your job submission command. You issue it, kill it. WMS job submit, flag A, flag O, job ID, photos.jdl, there's that. Then from there you will get the feedback. It will tell you your job was successfully submitted to the VM proxy. Then from there it will tell you where it's submitted, and then it will give you the identifier. And then from there you can issue that command, the delete WMS job status, flag I, job ID. Then it will tell you that it's running successfully, submitted when and at what time, date, and all those important particulars. Then from there you can check your job output issuing that command, the first one underlined in red. Then it will tell you job get output outcome, and then you can see those are the files there. And then from there you can upload them. You can download them once you've got the unique identity of the file in grid. Then from there, this is the health integrated system I said we proposed to our government in South Africa to solve one of the challenges we have in health. So the main aim of the system is to come up with a system that will be integrated with our grid. So the system will be a centralized system that addresses the issue of patient confidentiality and medical records. So basically the system will be highly encrypted, and will do data encryption. So as you can see on my left hand side is the end part of the system, and then in the middle we've got the firewall. Then we can basically firewall each and every terminal, then do a data encryption on that. So you can see here we've got workstations, your laptops, your desktops, your what do you call this, your iPads. And then from there, this is where the users are. These are our doctors and people who work in the hospital or nurse. So they will be able to access the files from this and update them live and put them back to the system. In this case, it will be easier to access your file wherever you go within the country. You don't have to open a new file everywhere you go. That's one of the benefits. Then we need grid for high performance computing. We need the information to be ready as soon as possible. We don't have to wait. Then if we want the file of SM Mothwa, we can quickly fetch it. Then you will receive treatment from the doctor. Then in this system we can easily allocate doctors where they are needed the most. We can sort out the issue of medication procurement and other existing problems. So we came up with this system as an application of grid. And then from there I can conclude that all the basics and the concepts and the technologies about Gilead were successfully learned and comprehended. And then we just have to wait for the results in order to conclude that everything went well. Then I can say from now on, it's very important for a research student to know about grid, because in every sector that requires high data processing, you might end up requiring grid services. So I think in biology, in high energy physics as usual, and in medicine, we can need grid computing, as we have already came up with a system for a medical. And then in astronomy, astrophysics, in weather services, and in quantum chemistry or quantum biology, we might need this to simulate complex processes and handle experimental data. And then from there, I would say thanks in a nutshell. That's what I've learned, and there's more to this. Thank you very much.